So it was found that teams using DevOps spend 60% less time on average handling tickets than traditional ops teams, based on a strong DM study from last year. In the next few minutes, I'll break down with data what DevOps actually is and how it works, along with how it can save your team time and money. So, we're going to cover what DevOps is, the core principles, and then how your team can use it to deploy faster. Whether you're a stakeholder or an employee, DevOps will make you more valuable. For a business, it means that you can have faster releases, fewer outages, and a stronger competitive advantage. And for employees, it means less time spent on tedious or tasks and more time solving high leverage problems. A big part of DevOps is eliminating toil, which is the manual, repetitive work that doesn't add long term value and doesn't scale. Toil includes things like manually configuring servers, troubleshooting the same recurring issues, or deploying code by hand. These tasks drain time and energy, but don't contribute to the innovation or the growth of the business. Worse, toil will lead to burnout and bottlenecks where highly skilled engineers are stuck doing work that should be automated. In DevOps, our goal is to always automate ourselves out of a job. Not in the sense of replacing ourselves or replacing others, but we free up our own time to work on higher leverage activities. Instead of firefighting production issues or running manual deployments, teams can focus on improving system reliability, optimizing performance, and delivering features that drive business value. The less toil an organization has, the more efficient and scalable it comes. Traditionally, developers will write their code and then they chuck it over to the wall to the operations teams, and there's a very distinct set of responsibilities between those two teams. IT focuses on reliability and security, where the software developers focus on shipping features and bug fixes. DevOps, though, eliminates these silos because it aligns incentives of the two teams. The goal is simple: develop and release software faster, more reliably, and with fewer issues. So instead of waiting weeks or months to push changes, we can just deploy in hours or minutes. DevOps enables continuous incremental changes, small updates that are tested and deployed constantly, reducing the downtime and making the software more resilient. Now that you understand what DevOps is, let's talk about why it's so valuable for your team. So, if your team builds software or relies on digital services, you probably wouldn't be watching this if that's not the case. DevOps isn't just useful, it's essential. So, the first benefit is faster deployments. With traditional IT processes, new features and updates can take weeks or even months to roll out. DevOps enables rapid, automated deployments, allowing the businesses to push updates daily or even multiple times a day, which means we can innovate faster and respond to bugs quicker. A lot of people are scared that with this speed of deployment that will end up increasing the rate of outages or recovery time, but it actually reduces both of them. So downtime costs money within a business. Every second you're down, you're draining some kind of revenue. DevOps, however, incorporates automated testing, monitoring, and failover mechanisms to catch issues before they reach customers. If something does go wrong, teams can roll back changes instantly because everything's stored in Git, or they can deploy a fix within minutes, not hours. It also allows us to lower our costs because we have so many manual processes in place that automating that infrastructure and the deployment, it reduces the human error and cuts down on the IT overhead, so it frees up the engineers to just focus on shipping. The last thing, scalability. When you build these environments to be ephemeral, it allows you to scale up or down as needed rather than having a very frigid infrastructure. So now that you know what it is, let's go ahead and break down how DevOps actually works. So there's five key pillars that I like to talk about when talking about DevOps. The first one's automation. Manual deployments and testing infrastructure not only slow teams down, but they introduce risk. When someone has to manually deploy something, say they're SSHing into a machine, or if they're running some kind of deployment command from their own CLI, there's a risk that there's some kind of dependency on their system that doesn't exist in the live environment. And these types of bugs become extremely difficult to track down because you don't have everything configured as code. So with that automation, we're able to not only reduce the time that we have engineers doing repetitive tasks, but we also reduce the risk of them making an error because things are simple and they're just following a checklist and half paying attention, which is to be expected when you've done the same tasks a dozen times in a single week. Next up, CI/CD. So this is continuous integration and continuous delivery. CI/CD is about how we can make change as incremental as possible. So instead of waiting for the end of the month to do one huge deployment, let's just deploy every time there's a change. And then if things go wrong, we can roll back that single change. We don't have to roll back the entire month of progress that we made and find what the problem was. You get a history that just builds up over time. And as soon as you introduce an error, you know what commit it came from. And not only that, but it allows for a quicker developer feedback loop. So this is something I stress a lot. We want the developers to know that there's a problem with their code as soon as they wrote it or as early as possible. If they have to wait till the end of the month to figure out that their code's bad that they wrote on the first of the month, then it's going to take them a lot more time to fix than if they find out 2 minutes after writing it. Next up, monitoring. So monitoring is what allows us to find problems before they occur. You've probably worked on some kind of small project where you have a customer coming to you to tell you that there's a problem. And that never looks good, but especially when you get to a large scale business, like if you're running Amazon and you go down for an hour, that could be millions in revenue lost. But because of that, I think there's a lot of emphasis at the large scale, but not so much at the smaller scale. But I think building in monitoring early in your process, like while you're designing these solutions, helps you to understand what the important risks are of the solution, but it also gives you data to back your decisions on what you need to be prioritizing at the time. The last pillar is security. So you'll often hear DevOps engineers called as DevSecOps engineers. I don't really like that term. I think that DevOps already embodies security and you need to know it as a DevOps engineer, but some people like to call it that. So so this was something that I actually avoided to start, and I wanted to build out the infrastructure in the CI/CD and just let IT handle the security. But I realized that if you're able to get a good grasp on this security early on, like same with the monitoring, you want to do it before you start building. It helps to make the operations team so much more confident in your ability to deploy and ship a solution that it makes things easier because they trust you and they're a lot quicker to get on the same page as you when you're ready to ship something. And the other thing is that this could be one of the largest risks in your business. I work a lot in sensitive data, and if we didn't follow our compliance requirements, this could be a massive fine. So finding ways to reduce vulnerabilities and get them fixed as early as possible, as well as ensuring that regulatory compliance, whether that be encryption or networking, whatever it might be, they shouldn't be an afterthought. So from here, you should probably look at what your team or your business is currently doing out of these pillars that I just mentioned and see what you need to improve on. I'm sure there's something. All of these are scales. You're never going to have them perfect, but you want to see which one you're the weakest in and start working on that to make it better. And so you're probably thinking all this sounds great, but what does it really look like in practice? So here's an example that I had. I'm a consultant and we work for a government agency. And this agency did a lot of things good. They had a platform as a service model. So you could come to a site and put in a request for a server and you could configure the server as you need. And they had some pre-templated out Terraform scripts that when you submitted it, it would make an API call and build a server in a cloud environment or on premise, whatever you chose. A lot of really good things there. But that build was taking about an hour to 2 hours for every time a customer would request something. And a lot of it was things that were repetitive. Sure, there was some customization per client, but a lot of it was installing the same exact software every single time that they requested it after they requested it. So they were heavily using Ansible, which it was good that they were using it, but just changing where we ran the Ansible in that process, so you think about shifting left in the process, had a huge impact on the result. So these platform servers were built from machine images or like templates, you can think. So on AWS, we had Amazon machine images that it's an EC2 image and then you bake in whatever changes that you need and then you can copy that as a template. So then you can invoke that template rather than a fresh EC2 image. Now, we had an engineer that was spending about 8 hours a month every single month at this point to go in and make the changes to update the server and get a fresh template out. So what we ended up doing is we used HashiCorp Packer to install their Ansible onto the templated machine image, and we would build a new image every single month. So we used a Git action to run this job on the first of the month, and it would go in and take a base EC2 image and then run our Ansible against it to install everything and create a new template out of that. So we had a fresh image on the first of every single month. And it was very little shift because we just invoked the same Ansible roles that were being called after the deployment and called it before the deployment. So what this resulted in was now that engineer is no longer spending 8 hours a month, and this maybe took us 1 to 2 days to get implemented. So for 1 to 2 days of work, we saved 96 labor hours per year, which at 150 an hour, that would be $15,000 in savings every single year from now on. And it also reduced the customer fulfillment time. So when I go in and request a server, how long does that server take to come back? By as much as 50% in some scenarios. So we now have happier customers because they get their stuff faster and we're saving money every month. Our goal here is that we want to continue to find high leverage activities. So that was the best use of our time at that point in time. And now we want to move up. How can we save 20,000 a year? And these savings just keep stacking up while also making the customer benefit even better. And so that's how we end up prioritizing our work to reduce toil and drive customer satisfaction at the same time. And if you're interested in a more hands-on video of how DevOps can fully automate your deployment pipeline, check out this video of how I deployed Kubernetes with just one click.